Okay, so welcome back to the second part. What I would like to thank you right now, maybe you've seen the great team from Tide GmbH. We're quite excited about it and very proud that we managed this joint venture. This allows actually to spread the knowledge and all the great speaks we have here to the world. So many thanks to Tide GmbH and the team that's helping us in a very professional manner. Thank you very much.
So we're going to continue. Going back to Malte's talk. So Malte said for AI you need data and computation. Malte gave you input about the data part, and Will's going to give you input about the computation part. Welcome, Will, from Verne Global.
Thank you very much. So just raise the hands in the audience. How many people are actually doing things with AI at the moment?
Can you repeat that?
Yes, how many people are actually working with AI? Okay, how many people are looking to go into things with AI? Okay, and how many people are just here for the beers? Right. So what I'm going to talk about is scaling your AI, because I'll go through and actually try to walk you through the journey that I've been on. I've only got 8 slides, yeah, so I'm going to try and talk slowly. But if you do have any questions, please raise your hand or just shout away, okay? And I'll make sure I ignore you as I carry on talking. So this is thanks to marketing. This is me, just to make sure you talk to the right person. I'm a product manager for Verne Global. And so what my role involves is actually looking after a product that we've got called HPC Direct, which later on I'll go through and actually more in detail, actually how it's helping people to actually do things with AI and also HPC as well. So Verne, who are we? Verne Global has got a data center in Iceland. Yeah, we're not a really nice Icelandic company, we're more of a UK-based company, but our data center is actually in Iceland. We believe the fact that we're actually offering compute, yeah, at an industrial scale, yeah, to actually allow you guys to go through and do what you want to do regarding AI, okay? We actually acquired a NATO base around about 2002, which was kind of left behind by the US military. And then from there, we pretty much knocked it down, yeah, and then we actually built on top of it, yeah, our data center from the ground up, okay? Now, you may ask the question, why Iceland? Iceland itself is actually, I think, it's a cool place to go. But second to that as well is that we've got abundant amount of energy based on geothermal, and also cooling, yeah, is also freely available as well. Okay, it makes it ideal place, yeah, for people to go through and actually locate their computing hardware. Customers we got here are like BMW. Now BMW is a very interesting case because they've been a long time customer of Verne Global. Everybody's heard of the BMW i8. Yeah, when BMW wants to go through and actually engineer the i8, yeah, they came to Verne to actually go through and use a data center. They wanted everything to be green, yeah, all the way across the board. Okay, so what they did is that they located their hardware to Verne Global Data Center in Iceland. Yeah, they did all the computation, the design, the engineering, everything, yeah, from their computers based in Iceland. Okay, then from there they actually then built it, whether it be in Stuttgart, whether it's actually been in the US, they built it from there. So the whole green story follows on from there. Another great success story that we've also got is DeepL. Yeah, DeepL has been using Verne Global facility to actually do natural language progression, yeah, to actually combat the Google Translate. For those of you that have never tried it, please go onto the website and have a look at it as well. Yeah, but it's also another fantastic tool as well. The Earlham Institute as well, another organisation that goes for users, as well as another car company called Volkswagen, which I'm sure you've all heard of, yeah, at the same time. Okay. Now, as I've said, yeah, our data center is 100% renewable energy. Okay, so when people are moving to AI, and again, this is something I'll cover later on, is that you need to think about cost. Okay, and energy plays a big part, yeah, in all of this. Yeah, but energy, exactly how you're going to go for user. A data center down the road, yeah, needs to get the power to it. Yeah, well, for us, we draw the energy from the ground. Okay, and from there, we can actually go for and drive all this machine equipment that we've actually got as well. It also means that when you actually got this abundant amount of energy, which is very, very cheap, yeah, at the same time. It means that institutions have more money to go from buy and spend on their hardware as well. So rather than saying normally you can only have, is that a question in the back? No. So rather than saying the fact that you're going to spend 80% of your budget on hardware and 10% on energy to actually power the machines and another 10% to cool it as well, yeah, it makes it easier to relocate it to Iceland, okay? Right, so we're already, and I'm giving these talks, yeah, based on GPUs. Okay. Now, earlier on, I asked how many of you actually moving into doing things with AI. There's a few hands that went up, but in reality, GPUs have been around for quite some time. Okay. I mean, me coming back from an HPC background, I've seen organisations that's been using GPU for a lot of like interesting projects. Yeah, as well. They'll be using GPU to do a lot of things. Yeah, but now it's coming to the mainstream. People are actually racing to go through it and get it done. But is CPUs dead? Yeah, that's the other question as well. Yeah, I don't believe CPUs dead. CPUs got a long, long way to go. Yeah, onto the point we get to where we can actually have a GPU servers that you can boot straight into the operating system and actually run from there. Yeah, CPUs will actually be around. But CPUs are also, yeah, getting, yeah, faster as well. Not on the scale of GPUs, yeah, but they're getting faster and actually get more intelligent in what they're doing as well. So what's driving the change for GPUs? Okay, and I think one of the big things that's driving the change for GPUs, yeah, is our hunger, yeah, to go through and get things to go faster. Is our hunger to go from deep analytical or solve analytical problems, yeah, as well. Is our hunger to go through and do, automation, bring it into the real world. Okay, CPUs were designed to be serial, yeah, and actually the way that they actually process things as well. But GPUs were designed to be parallel. They themselves have got their limitations as well. Okay, coming from HPC background, with CPUs, yeah, what you have is what you call a parallel workload. Yeah, which is you've got multiple amounts of computers stacked together to actually solve a problem. Okay, that works quite well. With GPUs, you've got multiple GPUs in one server. Yeah, technology is not there yet to allow you to actually have a fast interconnect between the different kind of computers, yeah, scattered around from there. So what will happen is that an application will run inside a GPU. As it's running inside a GPU, it can use other GPUs inside the same server. But should you want to go through and use another server, so I can say one machine's got 4 GPUs, another machine's got 4 GPUs, and you want 6 GPUs to run your workload, the application will actually go from the interconnect between the two servers will become the bottleneck, yeah, because the network is not fast enough to keep up with how fast the GPUs are actually going. Yeah, they're actually working at the moment to make it even faster as things go progressive from there. So, in reality, CPU's got a long life ahead of it from there. But GPUs, yeah, we're all racing to go through and get it done. Nobody wants to be left behind regarding working out what, doing something in AI. Nobody wants to be left behind looking at what GPUs can do. Yeah, nobody wants to be left behind, yeah, and not being seen in doing something in AI as well. But what is the main caveats with GPUs? They're very expensive. Okay, AI, machine learning, deep learning, they all need GPUs. Okay, if you really want to go through and actually compete in the market, you need to go through and start using GPUs for that. As well, yeah, you're not sure how many GPUs you need. Okay, when you're working with CPUs, I mean, how many software engineers have we got in the audience, by the way? Okay, quite a few. Yeah, when you're actually going for engineering your software, yeah, on the actual CPUs, do you guys ever think about how many cores your application is actually using? Or do you just go through and just write your applications from there? So when it comes to actually doing that and scaling it as well, you've got to work out how many GPUs you actually go through and need. Yeah, you're going to get improved performance with GPUs. Yeah, but in reality, can your application scale to use 1, 2, 3, 4, 5, 6, 7, and everything else from there? Other people as well, yeah, want to have a hybrid GPU solution, yeah, as well. Yeah, because they're not cheap. Yeah, you may have a data center which has just purely got all CPUs inside it. The organization, yeah, can't afford to buy GPUs. Yeah, so what you need a way to actually work in-house, yeah, but bring GPUs online for you remotely as well. Okay? Now, the next big one as well is to redesign a data center. Yeah, a lot of people don't think about this at all. But if you think about a current data center, it's all based around CPUs. Yeah, our cooling calculations is done on CPUs. Yeah, our power draw is done around CPUs. Okay, yeah, everything we do is all around CPUs. Yeah, so in doing that as well, yeah, it means the fact that the expense of rebuilding and redesigning data centers actually goes up dramatically, yeah, as well. Recently, I'm not sure if you're aware, but NVIDIA also changed the pricing, yeah, for regarding the GPUs. They're the market leaders, yeah, in GPUs, and they changed the pricing. Because what they found out is that to combat the expense of GPUs, people are actually going for it and buying the cheaper residential cards, which are run about the 1080 Ti's. So what NVIDIA did, changed the rules. So it's saying the fact that if you can use it as a residential person to run one application, but any more than that, yeah, you're violating their actual license agreements. So it made it very hard for data centers to go through and actually fill the data center with all these kind of GPUs in a sense. So what does that mean for you guys on the street? You can go out and buy it, but if your organization wants to do really deep, deep learning or machine learning, anything else at all, yeah, then what you'll find is that you'll actually need to go through it and move up a scale, spend 5,000, 10,000, 20,000 on GPU machines and GPU servers from there as well. Another aspect as well, which is affecting the GPU expense, yeah, is how developers can actually access the GPUs when they need at the same time. Something that a lot of people don't think about, but again, developers need to get access to it. All different types. When you write your application, yeah, you may write it one specific GPU card. Okay, but later on, you may then want to go through and make sure that your application scales. So you can run on multiple GPUs as well. Okay, so where do you get a mix of GPUs as well? So you need to start looking at outside, like the Amazons, like Verne Global, yeah, the Microsoft and so on and so forth. You need to go somewhere, data centers have actually got a mix of GPUs you can go through and use. Because doing it yourself, again, becomes very expensive. Well, above all of it is going to cost a lot of money. Yeah, a lot of money which most companies have not actually budgeted for at all. Now we're back to data centers. As I said earlier on, the data center yesterday, yeah, were designed and built around CPUs. Okay, the AI workload you're doing, everything else, you all want to jump on the GPUs, get it done. Yeah, but the data center you're using are not geared for that at all. I'll give you a classic example. There was one incident where I was working working with a customer. Yeah, and they had 240,000 cores, yeah, in a cluster, and they had one job. That one job required all of the actual CPUs, yeah, inside that data center to run. Okay, as soon as that job starts, yeah, you can tell me what happens next. Any idea, anyone? No? What happens next? When that one job started, the power grid went down. Okay? And you ask yourself why. Okay, this is where data centers have to be very clever. And also this is how the workload is very clever as well. When that one job starts, the fans have to go to maximum. Okay? The cooling needs to be maximum as well. The power draw, yeah, is absolutely immense. Okay, and the networking fabric, yeah, is actually at a maximum as well. So every time they started this one job, everything went down. Okay, that's because, yes, they designed the actual data center to actually run with CPUs. Yeah, they calculated the power draw, they calculated the cooling, yeah, they calculated everything. But what they forgot about is that when you press the button to say go, yeah, is that it just couldn't handle it at all. Okay, now when you think about GPU side of things as well, which actually run a lot hotter, you know, draw a lot more and use a lot more resources, okay, data centers of yesterday, yeah, need to actually be able to be improved as well. Okay? Now cooling, yeah, leading on to that, is also optimized, yeah, for CPUs. Okay, you got air cool, you got water cool, you got salt water cooled, yeah, you got immersed in oil, yeah, you got immersed in water as well. Yeah, there's loads of different technologies out there to actually cool the actual stuff. But again, the data centers of yesterday, yeah, were designed for not the actual the sheer amount of compute that we're actually using at the moment. Scalability for CPUs, yeah, as well. Yeah, when they designed the data centers of yesterday, yeah, they say my data center is going to have 100,000 cores, yeah, or 10,000 cores, wherever you want. That's my data center is going to go for and have. But what then happens? Yeah, what happens is that your machine then becomes end of life. Yeah, when it comes to end of life, the hardware manufacturers bring out more machines, yeah, with more cores inside it. Yeah, they try to lower the power consumption, yeah, but instead, yeah, they bring in, because they got more cores, the power slightly rises again. Yeah, so again, you're back to square one. Workloads as well for data centers yesterday were designed for CPUs. Yeah, most of you applications you write, yeah, are all based on CPUs first before you get into GPUs. Okay, the workloads didn't understand what GPUs actually were doing, yeah, and what they actually require, what the resources require, and also how do you actually work, connectively as well. Software engineers and data centers yesterday also relies on CPUs as well. Yeah, now you may say, what has software engineering got to do with data center? Yeah, but the example I've given you earlier on about the whole, the grid going down, yeah, the engineers now need to go through and factor that in, yeah, as well. Okay, when the, like recently, I think about, 3-4 years ago, we had the actual Olympic Games in London, yeah, which probably is a good place, but also the worst place to actually have Olympic Games, yeah. Why is that? Because the power draw in London itself, yeah, is actually immense. Okay, then you've got Olympic Games, which is going on, lighting everything up as well. So most companies around were told to actually lower, yeah, the actual consumption, yeah, of CPU, of software. So what now happens is that if you're using CPU-based servers somewhere else, yeah, hardware vendors like Cray, yeah, can now track how much power you're actually using. That one job, yeah, how much is actually using. Think about it. Mathematically, it's quite a hard thing to go through and do. Yeah, you may be writing a bash script, yeah, or you may be writing a C application. Okay, but the hardware needs to track how much power this application is running is actually using. Yeah, and if you're using too much, if they cap it, yeah, or go through and kill it. So that's the expense that they're actually going through. That's the expense they're actually going. Their software engineers are actually doing engineering on CPUs as well in data centers. Okay, everything needs to work well. Interconnects yesterday were also designed for CPUs. They're getting faster. Yeah, they're getting a lot faster. Yeah, you've got interconnects like InfiniBand from Mellanox. Okay, but the old data centers of the world were actually designed just to use Ethernet. Okay, and now it's all going, next generation as well. Virtualization is also designed for CPUs originally. Yeah, again, inside a data center, you run your actual virtualization. You may say, what is that going to do with data centers? Well, you're packing more onto it. The machines are getting hotter. Okay, because they're getting hotter, they're running harder. They're running harder and running faster, yeah, as well. Okay, you then got to calculate how you're going to draw in the power from that as well. What is it going to cost you to keep that going at the same time? Yeah, the race to have everything virtualized doesn't mean the fact that you can just run everything you want. You've also got to think about what is the bill at the end of the day as well. So data centers need to become smarter. Today's data centers, yeah, need to be designed for CPUs, GPUs, and TPUs as well. Yeah, and those of you who don't know TPUs, those are the one that Google's brought out. Okay. Now, I'm going to use the term XCPUs from here, or rather XPU from here. So that means any kind of PU that comes across. Okay, data centers of today, yeah, need to be ready for AI, ML, yeah, and DL. Okay, I was having a conversation earlier on before this actually started. A lot of innovation is going to come around. Yeah, a lot of people are going to try new things. They're going to fail. They're going to try. They're going to fail. They're going to try. They're going to fail. Okay, but data centers need to keep on going. They need to be able to go through and be able to serve these things. Yeah, and there's a trick to actually going through and configuring your clusters as well, which I'll come to later on. Data centers need to be more efficient. Yeah, the way they cool, yeah, the machines as well. Yeah, for you to run your workload. Data centers need to have abundant power. Yeah, you don't want to get into a scenario where I should turn it on and say, I want to go for and run a task. Yeah, that one 15,000 cores or 15,000 GPUs, and all of a sudden everything goes down. Yeah, it needs to manage it. It needs to manage any kind of workload thrown against it. Data centers also need to be designed to scale for any kind of XPU as well. Yeah, so whatever generation comes in afterwards, so they need to be able to ready to actually account for the power draw and everything else from there as well. They also need to be workload aware. Okay, that workload aware is quite a long task, and it's also the next generation what people are actually looking at as well. Aware in the sense that they need to actually change the environment to meet the workload. Okay, it sounds pretty simple, but it's quite complex. Okay, when a workload comes along, when your application comes along, your machine learning application comes along, you need specific things in place, yeah, to run your workload. Okay, data centers need to be dynamically optimized to actually help you go through and do that as well. Okay, make sure your application runs faster at the same time. They will say, I just came from Frankfurt. There's a company called Hyperion, yeah, who do research and stats and everything else into the cloud, and now people are using the cloud data centers as well. And what they said is that between 10 to 15% performance, yeah, is what people lose, yeah, by going into the cloud, yeah, compared to running it locally. Okay, this is one of the reasons why data centers need to make sure that you don't lose things. It needs to become workload aware. It needs to be optimized. Yeah, you don't want to run your application, so one's running in San Francisco, one's running in Tokyo, yeah, one's running in Frankfurt. Okay, it needs to make sure the fact that I want to bring the compute closer into the data. It needs to think for itself as well. The software engineering as well today, yeah, needs to allow you to actually access any kind of XPU that you want as well. Okay, data centers need to allow you to actually play around, try new things, try new hardware, yeah, try new functionalities. They need to be able to help you as well. Interconnects, yeah, also needs to be maximized as well for XPUs. Yeah, and above all, virtualization, yeah, which we all love, yeah, but what they drive as well. Data centers of today, yeah, it needs to be able to allow you to offer you to scale up doing what kind of virtualizations you want. So that brings on to HPC Direct. Okay, HPC Direct is a product that we engineer from the ground up. Yeah, and what it does, it takes into account how you all want to go through and use and do your machine learning, deep learning, everything else from there as well. What it does, it actually is built by experts, yeah, using something called true HPC methodology. Yeah, and true HPC methodology is actually looking at the way that people use hardware, yeah, how people use data centers, yeah, how people use storage, yeah, how people use the interconnects, yeah, and everything else. Working out the optimal way, yeah, for you guys to actually access that function. So that 10 to 15% that was actually mentioned by Hyperion, yeah, doesn't come into play anymore. Okay, you need true HPC as a foundational methodology to get everything else going. With HPC Direct as well, using an API and interface as well, you can go through and configure your environment to actually run your machine learning or deep learning, everything you want from there as well. But because we've actually built it from there, we've actually used the latest technology, yeah, to actually go through and spin up the environments as well. Okay, so what it does for you, yeah, in essence, is that it builds for you a cluster. Okay, this cluster is your own personal cluster, your environment, what you go through it and actually do some work on, yeah, as well, from there. From there, it's actually got for you, it's configured your interconnects for you at the same time. It's actually configured for you your storage. Yeah, it's configured for you the GPU that you may get access to. Yeah, if need be, it's also worked out, and the question earlier on, again, what kind of software stack do I need? Okay, it's actually configured the software stack to actually get you going, yeah, as well for you. So you've got an environment ready for you to go through and play, yeah, and try things on. Okay, this is what HPC Direct actually offers you. There's another question regarding data transfer. Okay, that's one of the big questions regarding moving things into the cloud. And yes, HPC Direct is inside the cloud as well. How do I move my 15 petabytes of data into the cloud to go through and process it? In reality, okay, how much of that 15 petabytes of data do people actually use now? Yeah, how much you actually use process day to day? Yeah, when you look at it, it's only in the small terabytes of data, if that. Okay, you may have 15 petabytes of information, but that 15 petabytes of information is something that you've actually had and kept for quite a long time. Okay, it's historical data. Yeah, so what do we do about moving the data across? Okay, we've got partners in place, yeah, that are able to shift your data. with guaranteed bandwidth, yeah, from where you are into the HPC Direct environment from there. We'll also build HPC Direct based on bare metal. Okay, coming from HPC environment, yeah, it means that speed is of the essence. Okay, why bare metal? A simple example in HPC. I've come across some scientists, yeah, who are actually developing or engineering software, yeah, on hardware. And what they do, yeah, is that they write their code so specific, yeah, that they actually talk directly to the actual chip. Okay, they tell it where the placement, yeah, or what cores you have to go through and run that application on. Okay, in a virtual environment, yeah, with multiple people doing this, yeah, you're all fighting for the same core space, yeah, which doesn't work at all. Okay, what bare metal gives you is direct access to that, to do that kind of low-level things you want to go through and do. Some people who write applications, yeah, for machine learning, okay, and also deep learning as well, want to go to that level at the same time. They want to go through and actually talk to the actual the cores themselves, yeah, to work out what is the fastest gates to actually move things around. HPC Direct is also optimized, yeah, for storage. There's a bit missing there, which is actually storage. Okay, what HPC Direct also offers you is the ability to actually have a shared storage environment, like what Amazon actually offers you at the same time. Yeah, but in order to run your workload, you need storage to actually, serve you as well. But what we also find is that people just want to come to us and say, I just want storage. I don't want compute. I just want storage as well. Okay, so it has to be offer you fast storage, whether based on the objects or parallel. It needs to be able to offer you that as well. And also the interconnect of HPC Direct, yeah, is also maximized as well for XCPUs as well at the same time. Yeah, we've got engineers there that work on HPC Direct, yeah, to go through and speed up, yeah, your environment for you, or they're monitoring all the way through. So what does it look like? It pretty much looks, have I got a pointer on there at all? Maybe not. So what does it look like? So on the right-hand side, you've got HPC Direct. Okay, and it gives you multiple ways where you can actually go through and actually interact with the cluster itself. So if you imagine this being your GPU cluster, okay, it's been built for you. It's been built for you with access, fast access to storage that you may want as well at the same time. On the left-hand side, you may have your HPC cluster. Okay, it'll be your own in-house cluster as well. Okay, it's designed to actually give you the different kind of models that I spoke about earlier on. Yeah, one of those models is that you've got on-site system where you want to go through and use an off-site system as well in the cloud. Okay, you want to actually dynamically extend your cluster. But not only that, but those people who are actually starting out doing things in AI, ML, and DL as well, yeah, you can forget the left-hand side. You can go straight down to the right-hand side. Yeah, it gives you a platform where you can start building these things from, yeah, as well. Okay, now storage as well. Yeah, it allows you to actually go through it and dynamically, yeah, transfer your data between the storage mechanism at the same time. Okay, the GPU scheduler, which is in place there, yeah, is designed to say, if you come on board and say, I want a 1080 Ti, or want a P100s, or want a V100s, whatever, yeah, it will go through it and actually make sure that you get the right GPU cluster for you to go through and work on as well. Not only that, yeah, but if you recall earlier on, I said that it's also workload as well. So if your workload is not GPU intensive, that it actually needs a virtual GPUs, it can go through and configure the environment for you, yeah, so you actually run, yeah, on a virtual GPU as well. Okay, so this is what we're doing, yeah, to actually go through and help you guys, yeah, move across as well. Yeah, this is what we've built, yeah, in our Icelandic data center. This is what we're actually offering, yeah, organizations out there. This is what we're actually inviting you guys to come and play with as well. I mean, most of you have actually seen the leaflets on your desk as well and everything else. Okay, we're actually giving you a chance to go through and play, yeah, with some of the leading, hardware that we've actually got on offer as well. And there we go. So if you all go to that website there, I've got one more slide to go, I believe, you'll be able to go through and actually enter in there. Well, what we do, we give you access to our free trial platform, yeah, and from there you can play with some GPUs, try things out and everything else. Now, one of the things we do as well, which is part of the competition as well, is that we'll put you into a free price rule. Because in Q4, we're going to go through all expenses paid trip. You have to come to see our data center in Iceland as well. Yeah, you can see how we've actually engineered our data center. Yeah, how people are actually using it. We will walk you through, talk you through as well. Yeah, where the energy comes from as well. How we're using it. How we're cooling the system as well. Yeah, how we're managing the data center autonomously as well and everything else. Yeah, so we've got a lot of people that come to this field trip. We've got a lot of organizations that want to see and feel. Yeah, because this is an opportunity that some people don't get at all. Yeah, work out what the cloud looks like. Yeah, beyond your computer. Okay, you can actually see what it actually, and also Iceland, as I said before, is also a very cool place at the same time. Okay, I love going there because it's just cool. All right. Right. So thank you very much. Have I got any questions at all?
I actually got a question to start with. So for the Iceland field trip, you have to sign up for the free GPU test out, and then
Yes.
you're gonna go into a draw, and then you guys draw
We guys
many
draw,
people
let you know, and then you come to Iceland. You can sit down if you want to. You can have a beer with me, yeah, because it gives me an excuse to go over to Iceland, yeah, as well.
Yeah.
But you'll see, it's not just a case of like you go to a data center, you're locked in there, looking at servers, just running with lights flashing. Yeah, because that's not be funny. Would that be boring? Yeah. So what you look at, we give you what a data center actually is. We give you reasons why we built it the way we've actually designed it from there. Okay. We then, believe it or not, we even take you out for a meal. Yeah, as well. Okay. There's food in Iceland. Yeah. We take you from and then we also take you to a one of the fresh natural spas as well. Yeah. So if you wanted to, you can actually, you know, while it's snowing outside, you can actually jump into a warm water as well. Okay, so we're planning a lot of activity. We don't just plan for you to go there and then literally just sit down and just look at servers with lights flashing. Yeah, we kind of explain the whole thing as well. And also while you're there, we'll give you an experience of Iceland at the same time. Okay?
Right, so now you know what you gotta do to go to Iceland. So any further questions for Will?
No? Oh, everybody's gone shy. Yeah.
All right. Well, he's going to be around. So may I ask you guys, and also, is Malta still here? Could you guys come to the stage, please? And also Sandra, are you still here as well? Is she not? All right, you guys as well. Ankush. Fabian.
Wow, full team. Right. Of course.
All right, so we got like an hour or more, like an hour and 50 minutes. We're going to be out of here by 10 or more to network. I don't yet know what's going to happen afterwards. Maybe we're going to go for like a bar or something. We'll let you know. So thank you all for coming. Thank you all for participating. And yeah, please give it up for our amazing speakers coming from Berlin and also UK,
London,
right?
yeah,
London.
UK.
That's crazy. Okay, thank you so much.
Thanks. Thanks, guys.
And yeah.